Uh, Hello, this is our team demo for Lab 1, CPEN 412 by Edward and Allison in case something goes horribly wrong and we can't make the lab. So going off the assignment 1 criteria, first we'll take a look at the on-chip ROM, which is over here. Here's our on-chip ROM fully connected. And then next, we'll look at the SRAM blocks, which is over here. So this entire block is 256 kilobyte RAM, which is made up of 432 kiloword SRAM blocks. And the way it's connected is basically all connections are the same for each of the 4 SRAM blocks, except for the signals generated by the SRAM block decoder here. So each of the 4 signals that corresponds with each of the 4 SRAM blocks are generated by a decoder, with the top 2 address lines used as decoder input. And we'll take a look in here for the decoder. Actually, we'll do that later. And each of the outputs of the SRAM block has a tri-state buffer connected to it, so that data contention wouldn't be an issue. And then now it's the SRAM decoder, which is over here. And basically this is all the code that was added. So if SRAM select high is true, and the top 2 address lines is 0, 0, then block 0 would be enabled. So the first 32K SRAM block would be enabled, and similarly for the other 4. So if SRAM select is high and the top 2 address lines is 0, 1, then block 1H would be enabled, and the same for the other 2. And then for the next criteria, able to download, program, and download the D1 successfully. This will be obvious when we show part B later, so yeah, this will be demonstrated later. Now for part B. So since we have the JYC downloaded, we don't have to manually upload the SOF file to the D1 board every time. So all we have to do is turn on the D1 board and then open up the hyperterminal. And it will automatically show up. And as you can see here, the names of both of our lab partners are displayed here whenever reset is clicked. So I'm clicking reset right now and it just shows up. So if we open the menu prompt here and we do a memory test, so TM, first the user will be prompted to either perform a byte test, word test, or a long word test. So we'll do a long word test first here. Option C. And then after selecting one of those options, the user will be prompted to choose one of the 4 patterns. So here we'll choose pattern C, which is a bunch of A's. And the user will be prompted to enter a start address, which is 8 digits. And as you can see, the prompt reminds the user that if a word or long word test is being performed, then the start and end addresses need to be even aligned. And if they're not, then an error message will occur, and we'll show that later. But now we'll enter a valid prompt first. and then a valid end address as well. And now it says test has passed successfully, and then we can verify that by opening up the memory. And there we'll see that from address 08020000 to 08020050, the memory has been filled with A's. And now we'll go through 2 more successful runs of the word test and the byte test. So we'll escape quickly and then TM words, and then we'll do the 6 pattern this time. Successful, and then we'll check the memory again. And you'll see the words have been overwritten with 6s, and the A's that were there are still there. And then now we'll do a byte test. We'll do the 2 pattern this time. And this time we'll write from the entire valid address space so that the progress display is shown. Because right now we have a progress display every 5,000 addresses. I believe the assignment said every 10K, but we did 5K. But the earlier 2 tests were at a really small address range, so the progress didn't show up, but this time we'll make it show up. So you can see every 5K address spaces, it'll tell you what address space it tested up to, and then whether it's successful. And this one passed successfully as well, and we dumped the memory. We'll see that bytes of 2s have been written in throughout this entire valid space. Yep, and then yeah, we showed the prompts are valid for these 2 criterias, and then valid start and end address prompt, and then displaying some sort of progress. And then we also showed through the memory dump that the memory test program functionality is behaving correctly. Now we're going to show that addresses out of range should return an error, or addresses that are not aligned properly. So for example, if we perform another test, let's do a word test, and then say we enter the start address in the valid range but not evenly aligned, so 0802 0001 and then 0802 0006. We'll say that word and long word tests require even address alignment as an error message. And just to demonstrate again, if we enter a start or end address that are out of range, so for example, we will enter 08000000, which is not in range. Say that addresses provided are invalid. And this will also show up if the end address is smaller than the start address. For the details of the implementations, please refer to our C code submitted in the zip file for assignment 1. And additionally, in the C code, when performing the memory tests, when reading back whether the inputs are as expected, it will return an error if the input if the value read from the address doesn't match the expected value. Again, refer to our C code for specifics, but we have tested this out by inserting some some incorrect data in the middle of sections, and the error values do indeed return. And then memory test program functionality. This one we showed with the D command already. And then 6 files. These files will be uploaded in the zip file. Student numbers, as shown earlier in the video, are displayed every time reset is pressed. And as we showed in the somewhere near the beginning of this video, the D1 board is able to auto boot with the JIC file without needing to upload the SOC or SOF file. And then, yeah, the explanation parts we did throughout the video, and that's our Lab 1 demo in case you can't make it. Thanks.